Microplastics, infertility, and the end of our story. A refined narration ready outline. The invisible invasion. A looming plastics now circulate through every ecosystem on Earth. Oceans, rivers, soil, food, water, and the air itself. Born from the breakdown of larger plastics, synthetic clothing, fibers, tire, dust, packaging, and industrial waste. These particles have become a permanent layer of the modern world. As of early 2026, scientists start detecting microplastics in places once thought unreachable. Human blood, lungs or tenders, testicles, ovaries, breast milk. The invasion is no longer environmental, it is biological.
The body under siege. New research shows microplastics can cross biological barriers and enter human cells. Once inside, they trigger inflammation, oxidative stress, and immune activation. The same pathways involved in chronic disease.
Scientists are investigating how these particles interfere with mitochondrial functions,
Cellular signaling,
DNA repair,
hormone receptors. The body recognizes microplastics as foreign, but it cannot break them down. This is not just pollution, it is a microscopic occupation. 3. The Infertility frontier, sperm, eggs, and testic. Early evidence is now pointing toward a disturbing possibility. Microplastics may be contributing to the global decline in fertility. Studies have found plastic particles in
human testicular tissue,
ovarian tissue,
human testicular tissue. Reduce solemn brass and glue, reduce sperm count and motility, altered sperm morphology, impaired egg development,
hormonal disruption, inflammation in reproductive organs,
possible genetic damage. Scientists are not yet declaring causation, but the correlations are growing harder to ignore.
The demographic cliff, fertility rates are falling worldwide, with many countries already below replacement level. If these trends accelerate, humanity faces
shrinking populations,
collapsing workforce numbers,
clinical care burdens,
economic contraction,
geopolitical instability. The existential question emerges: what happens when a species loses the ability to reproduce at scale? This is not a distant sci-fi scenario, it is a trajectory already visible in demographic data.
Wi-Fi beyond the horizon, solutions and survival.
Scientists are racing to develop
microplastic capturing filtration systems,
biodegradable material alternatives, hyperaccumulator plants and engineered microbes, improved wastewater treatment technologies. Policy shifts are beginning to target plastic production, waste management, and chemical regulation. Individuals can reduce exposure through choices in food storage, water filtration, and product selection, but systemic change is essential. The story ends with a call to action. We are the first generation to understand this threat, and the last with the power to prevent its worst outcome.